Okay, so today we're doing 3.9. I don't know if I'm going to get through logarithmic differentiation, which supposedly is not on the AP exam, but it's a helpful technique for doing complicated things. But for one of the proofs I need to do today, like I told you guys, limit as x goes to 0, sine x over x, that goes to 1. And the limit as h goes to 0, 1 minus cosine h over h equals 0. I need you guys to know this one. The way we did the other two was I was like, look at the graph, look what it does. So e to the x minus 1 divided by x, as x goes to 0, what does it look like? 1. And it is actually 0 over 0, but visually, looking at the graph, the limit is going to go to 1. So I need that for the thing that I'm going to do in a second. Today we're going to do derivatives of exponentials and logs. The homework is day 23. So we'll do all 4 of these, but really I see them just as 2 things. Just like the trig inverse, if you knew how to do the derivative of arc sine, put a negative on it and you now know how to do the derivative of arc cosine. But we need to remember these things first. The first one, log base a of b plus log base a of c. Anybody remember what's in here?
Log a b times c.
So addition across logs of like base become multiplied then. Ethan, what do you think subtraction across logs of like is divide? Guys, you remember the this thing?
You move it into the power.
So that coefficient out front becomes the power, and vice versa. I think I've warned you guys already. If in calculating something you got this answer, if it's free response, you can leave that. But if it's multiple choice, AP exam is not going to have that option on there. They will have the option that's natural log of 2. So you need to be good with your log things, properties, to be able to possibly mutate your correct answer to look like their correct answer. Does anybody remember, how would you type that in on a calculator, given that you don't have a TI-84 and know how to do the change? Cecilia, what do you do?
Log of base 2 over log base 7, or log of 2 over log of 7, not base.
Base goes in the basement. So log B over log A. And in here, generally, you can do any base you want. Like in computer science, my background, base 2, base 8, base 16, we would do it all the time. And that's not a button on the calculator. But it's also natural log of B over natural log of A. Base goes in the basement. What base is implied if it's just log?
10.
10. What base is implied for natural log?
E.
Okay, yeah. So just checking to see if you guys remember logs. So if you're kind of allergic to them, Alex is just saying it's too early in the morning, that's all. Okay. All right. Okay. So again, for all of the derivatives that I'm showing you guys, you don't need to do the proofs of them, you just need to know the patterns. So I'll show you the graph. So don't actually type it in on your calculator. I'm worried about time. Oh yeah, I can't touch. Yes. Okay. All right, so in here, I've put in e to the x, and I don't know if you guys know this, but if you arrow all the way to the left, and you hit enter once, it changes the style that it's gonna graph. So this is gonna, the top one's gonna graph a skinny line, the bottom one's gonna graph a thick line. So saying go, here comes the skinny line, and now here comes the fat line. It looks like they're right on top of each other. But, to be really sure, I'm going to check the table. Second table, every single number is exactly the same. Okay. So, cool. But maybe let's try the limit definition of derivative. Ari, do you remember what that is?
Okay, I remember.
Well, hang on. I asked Ari.
When then as h approaches 0, and then you do f of x plus h, so yeah, f of the x plus h minus e to the x over h.
Okay. So f of x plus h minus f of x. Miriam, how do I pull apart this exponent thing here?
Well, you could factor, you could put everything to the natural log.
Hang on. What is x squared times x to the fifth?
X to the 10th, x to the 7th, x to the 7th.
X to the seventh. So you added these two to get that. Okay, so I'm asking you to go this direction. How do I do that with these guys?
So e to the x plus h minus x.
It's going to be e to the x times e to the h minus, then copying the rest of it down. You guys okay with that? Yeah, we need to be comfortable with pulling apart those exponents, and it's tricky. Brooke, what can I factor out of the top?
X, e to the x.
E to the x. And Clara. What did this do? You, Clara. From the warm-up, from the, hey, look at this graph, what happens as h goes to 0, what does this part do?
That goes to 1.
This goes to 1. So the derivative of e to the x, by limit definition of derivative, is e to the x. Yes.
Is that something we just have to remember?
Yes.
Okay.
Like I said, you're never going to have to repeat the proofs. I have a few sassy students who do because they were bored. Okay, Teddy. And some people it's because they don't remember, but they're like, oh wait, I can figure this out. You have the time to do that on the test, go you, and just remember the derivative of e to the x is e to the x. Here it is written in chain. So try that. Sydney, how do I do the derivative of e to the stuff?
It would be e to the stuff times the derivative of
Okay, so e to the stuff is e to the stuff. And then what's that?
the derivative of stuff.
The derivative of stuff. So in this case, the derivative of tangent is,
Is it secant squared?
yes, secant squared. The ceiling is so smart. You guys are like, and the answer is up there. Someone wrote them all on the ceiling tiles. They didn't actually. Okay, so that's what this notation means, is due chain. And that's the problem you just did.
Oh,
Ah. Okay. Now, all right, I know the derivative of e to the x. I want to figure out a to the x. First thing I need to do, what undoes e? What math operation? ln. So can I do e and ln of something and still leave it alone? Like, does this still equal a to the x?
no.
No?
Actually, yeah.
Because e and ln are inverses of each other. Okay, all right, this is good. And Preston, was it you that told us what to, I don't remember who told us. What can I do with that little exponent thing?
Same rule.
Just looking at properties of logs that we did in the beginning.
Put it in front of the natural log.
So this is e to the x times natural log of a. All right. And this is still all of that. Okay. All right. Camden, a is some number. So what is natural log of a? Is it a number or is it a variable?
It's a variable, or it's a number.
Okay, so it's pick a number, any number, but it's a number. So this is like asking what's the derivative of 3 to the x? We picked a number. So Sydney said a second ago, the derivative of e to the stuff is e to the stuff. So here we go, e to the stuff. And then she said times derivative of stuff. So Hadley, what is the derivative of this x ln a? Camden said ln a is just a number. So if this was 2x, what's the derivative of 2x? Just 2. So this is x times yucky looking number. So just yucky looking number. Okay. That still looks gross. But Eitan, from the beginning, what did this equal?
E to the x.
It equaled
A to the x.
a to the x. So the derivative pattern for these guys is natural log of a times a to the x. So a to the stuff is a to the stuff, but it's not e. So it means this effectively conversion. It's a cheap knockoff. It's like Canadian quarters. No offense to Canadians. So there's an adjustment. It's not actually e, so we have this conversion rate, natural log of a. Yeah.
You should do like the product rule instead of just canceling out the x stuff when you're getting ln of a.
Okay, let me show this pattern.
Alright.
So here, 3 to the stuff is the derivative of 3 to the stuff. Derivative of x is just x. And then I have this adjustment. So you're saying do chain rule with,
Product.
okay, I'm not doing product rule. I'm doing the derivative of this thing.
Yeah, for the chain rule part, when you're doing the derivative of the x to the
Okay.
Great.
Okay, so derivative of e to the 5x, that's e to the 5x, because e to the stuff is e to the stuff. Do I need to do chain, not chain rule, but product rule here? I do need to do chain rule. So the 5 is what comes out, right?
Yeah.
This is just a number. Like in this case, it was natural log of 3. It's just a number. It's a number that you guys don't like. Because it's not like 4. It's not one of your counting fingers, natural log of 3, but that's just it. So here's the pattern. A to the stuff is a to the stuff times natural log of a. And don't forget to do chain rule. And a can't be 1, it can't be negative. And they don't ask this often, but it's not crazy.
Do they always have to be a singular number?
What do you mean singular number? Single
Like-
digit or?
What if it had x in it?
Oh, well, that's the thing that we might not get to today. That's logarithmic differentiation.
How is ln of a just a number if like a changes?
Okay,
A is a variable too,
so-
right?
these are y equals 2 to the x, y equals 17.3 to the x. Once you pick that number, like that's what this is saying is pick a number, any number. Now that you have the number in your head, that's what that number to the x. So
But
yes.
it's not like it's two functions.
yes, correct.
Yeah.
This you needed to know the a value in advance.
Okay.
Like it's a fixed number. So what Sydney's saying is both of them have x in it.
Yeah.
That's a different thing that we may or may not get to today. Okay. Okay. You ready? I love this one. So when we did the trig inverse, I was like, I don't know what arc sine is. I needed to undo that. Massimo, how do I undo natural log? E. So I'm gonna E both sides. So I have e to the y equals, Luke, what is e to the natural log of x? X. Cool. Jasper, what is the derivative of e to the y with respect to x? Derivative of e to the stuff is e to the stuff times derivative of stuff. What's derivative of stuff in this case? dy dx, implicit differentiation. What's the derivative of x?
dx over dx, that's 1.
Just 1. Yep. Huh. And just like the trig one, I have the answer in terms of y. I don't want y. How do I get rid of it? Do I know what e to the y is? X. So the derivative of natural log of x is just 1 over x. That's pretty easy. This e to the x is e to the x. Natural log of stuff is 1 over stuff. This isn't hard. Proving it was a little slick. But... question? No? And again, you don't need to do the proofs. It's to motivate you to memorize the pattern. So there's the pattern with chain rule. So do that one. Oh, yeah. So use the pattern. The pattern is whatever stuff. That's derivatives. Just how we do this.
Use the pattern, so you put 1 over 3x squared, and then you multiply it by the derivative of 3x squared,
Which is?
6x.
So 1 over stuff times the derivative of stuff. Does anything reduce? Colette, what do we get when,
That's in the numerator.
Colette, what do we get?
When you get 6x over 3x, that's 2 over x.
Okay. All right, so there's one more pattern. I never use this pattern. This one, it's more difficult to memorize the thing than to use what I already know. Camden, in the beginning, we did change of base. How do I make this natural log instead of log base A?
ln x over ln
And Nick, this one, A is also a number that you had to pick in advance. So like log base 3 of x. It's not a variable, it's a placeholder for some number, any number that you've chosen, but it's fixed once you've done it. So natural log of A here, is that a number or is that a variable?
a.
It's a number.
It's going to be a number. So like in this one, this is natural log of x over natural log of 3. Natural log of 3 is just a number. So you had to have chosen your A value. All right, so just to make this hopefully stand out more, that's just a constant. Sophie, what would the derivative of this pattern be? So 1.
Well, you know that the derivative of ln x is 1 over x, so would it be like, it would be times 1 over, or yeah, 1 over stuff times.
1 over stuff, this being stuff, times the derivative of stuff in this case was just a 1. So the derivative pattern in general, 1 over x times natural log of whatever that base was. So I don't memorize this pattern. I do change of base and then I do the derivative of ln.
And so at the first step, why did you switch from log to
Because I don't know how to do the derivative of log base A, but I just derived how to do the derivative of natural log. So if I turn everything into a base that I can do the derivative of, it makes it easier.
Wait, how do you go from 3 to 4 step from the 1 over to the last one?
So from here to there?
Yeah.
Okay, this is just a constant, so I'm gonna leave the constant. So 1 over natural log of A is still there. It's like derivative of 2x is 2, derivative of this is gonna have that 1 over ln A. On the previous thing we just did, the derivative of natural log of stuff is 1 over stuff. And-
Okay.
Okay, there were friends in the basement already.
Oh, because we knew what it was, we could just put it in. Okay.
So there's a pattern in chain rule alma. You know, the arm roll, right? Anybody know this one? Clearly not. Okay. Cool. And I don't know why, but these are called transcendentals. I didn't know that until I was looking at delta map. E to the x and natural log. Okay, so I see this as really only needing to know those two. A to the stuff, the derivative of A to the stuff is A to the stuff, but it's not E, so you need to do this conversion factor. It's really natural log of A over natural log of B, but natural log of B is just 1. This guy, do change of base of this, and you don't need to remember this one, you just keep doing natural log. Okay. You ready for the fancy stuff? I'm glad you do not share my enthusiasm. It's fun, it's cool, and yeah, I'm now motivated to really show you because it makes chapter 8 easier. Okay. I don't want you to do these, I want you to tell me the strategy. This was a reaction to years ago, someone else on a quiz. What's the strategy to doing these easily? Do I do quotient rule or is there something else?
You can do, quotient rule.
I don't want to do quotient rule, that's poopy. Millette?
Can you split it up into 9?
I call these divide and conquer. And don't stop there. Like, if you guys need to write it as negative exponents, x to the negative 9, but really it's this one. I've had students split it up and then not reduce, and they did quotient rule here. This is 19 over x to the 6th. So it's just power rule. Ooh, that's a y. So multiply by the power, lower the power, whatever 19 times 6 is. 20, yeah. Multiply by the power, lower the power. Be careful of the signs. And this one, you would split it up into 3 pieces. And reduce. So 2x to the 3rd, and I haven't done the derivative yet. This is a thing that I've noticed, it'll catch maybe 2 or 3 of you, is you've already done work, so you think you're done. You'll get here and be like, I did stuff, so I'm done. We haven't even done the derivative yet. This is just algebra.
How do you determine whether to use the quotient rule or to just divide it?
Looking at the denominator, if it's something tiny and simple, that will come out of everybody up top. Divide it up, because otherwise, this as a quotient rule is ungodly. And some of you did that on the quiz, and you got there, but boy, it was painful. And a note about retakes. There are 2 quizzes, the prereq quiz and 3.1 and 3.4. If you wish to do a retake, you need to do quiz corrections. I have instructions to give you if you want them. They're also posted online. And you need to do those quiz corrections before you take the quiz and the retake. And that retake is the last full week of October. Brain Trust that was here in the morning. Did we just decide on a day that's best in that week? They want them responsibility of choosing. So it will be someday in the October 23rd through the 28th. I will let you know. Do you guys know, is there like a big test day in there? Some IB, something or other? Not yet. Okay, well, so it'll be at lunch someday that week. And I'll send out a Google form. You want to take this one, that one, or you're happy with where you are. Also, like the point of retakes is you had a bad day, not, well, I had an 88 and I'm going to take it again because I want a higher score. Thank the class of 2017, they broke me. It used to be I would let you retake any quiz. There were 80% of the students that took the retake because they wanted a higher grade than their 92. I know I can do better. Excuse me, you have an A. Get out. I was really angry. And now there's not that option anymore. Roxanne?
Do you take the higher score or the lower score?
If you are going through the trouble to retake a quiz, you better get a higher grade. So this is to discourage people that got a 93 and they are going to retake. So if your grade's pretty good, leave it alone, is the general comment. Okay. Don't write this down, just there is a process called logarithmic differentiation, and when is it used? For things that Sydney brought up and that Nick had mentioned. Here we have a moving target to a moving target. X is a variable. Cosine of X is also a variable. If this is variable to a number, I just do power rule, multiply by the power, lower the power. And we just did this pattern. It's a fixed number to a variable. 3 to the stuff is 3 to the stuff times natural log of 3. Can I power rule? No, because cosine x is the variable. So does that mean we do this pattern? No, the base is moving also. This is the hint. What do you think the first step is that we're going to have to do in the problem? Maybe do log of both sides. All right. All right, why is that helpful? What can I do with the exponent?
You can then do the, put it on the outside.
Comes down as a coefficient. And now I can do the derivative of all these things. I know what they are. Let's see. Alex, what is the derivative of natural log of y with respect to y? 1 over stuff times derivative of stuff. Derivative of y with respect to x? dy dx. Fiona, here on the this side, it's a product, so do product rule. What is
Natural log x times negative sine x plus cosine x times 1 over x.
perfect? Just did it backwards, but that's okay.
Sorry.
Totally allowed. I just hate it that way. So she did the derivative of the first, derivative of cosine is negative sine, left the second alone, plus now the first, do the derivative of the second. So dy dx equals y times negative sine x natural log of x oops, of x plus cosine over x. Camden, I don't want y in it. How do I, what is y?
X to cosine x.
So in effort to not repeat too much writing, it doesn't clean up, that's it. It's just gross.
So,
What's that?
it's so ugly.
It's beautiful because it's math and it's in color. Pretty.
Where does the red come from?
Okay, here I multiplied by y on both sides. And I was lazy. I had the y there and I asked Camden, what did y equal? Because I want to replace it. And he said, from the very beginning, oh, y was the thing I had to do the derivative of in the first place. So logarithmic differentiation is used when you have a moving target to a moving target. But I also wanted to show you another place that it's used. I've never done this problem before. I did it this morning and I was like, oh, that's cool. It's kind of gross too. The derivative of this thing, if we were to do this by hand, it's power rule, quotient rule, product rule, and a whole lot of chain rule, like yuck, like super yuck. But the solution, or the reason that this is in this section, which I will not ask you anything like this on the test, I just want to show you like, holy crap. Doing the log of both sides, that thing comes down as a coefficient. And then log has this pretty property that multiplication up top becomes plus, division becomes minus. I can bring those coefficients down, so I'm not doing power rule anymore, it's just a constant. And the derivative of natural log is just 1 over stuff times derivative of stuff. And I get all these things. And then I gotta multiply by the y in the end, and I get this big gross purple thing, but I got it quickly versus all the like yucky, irritating business. Hadley's like, cool, and you said we don't have to do this? Yeah.
So is there a general pattern for this, or?
A general pattern for this. I've never shown these guys before. But if it's really ugly, possibly doing natural log so that you can split up the quotient. But again, I have not seen anything like this on the AP exam either. They've dropped it in like the 90s. I know, the 90s. I was still in high school then, actually I wasn't. Anyway, all right, so that's all the things. Did you guys have questions on the delta math inverse stuff? Because your book does not cover it well, so that's why that optional thing was out there. Okay, so I will open the homework and let you start that if I can find it.